Today is February the 19th of 2013, and we're going to document a...
It's a Tone Master. Some were made by Magnatone, and this one I think was made by Valco, probably around 1956. Tiny little cabinet, but they're really famous for really good quality vintage tone. It's very similar to a Champ design, 6V6, 5Y3, and one difference would be on the preamp tube. We have a 6SJ7 preamp tube. This one, the speaker's been changed, but everything else is the same. Transformers, filter capacitors have been changed, but this is stock enough and original enough that it'll give us a real insight into the performance of amps from this vintage.
Okay. We've got it, we will plug it in here in just a second. Now we've actually got our 8 ohm load already up to these precision resistors back to our equipment, and we'll be driving it at 500 hertz, a kilohertz, a couple of different frequencies, and measuring its THD here. But most important, the goal that Doug and I have taken on is documenting the harmonic profile. The video just a few days ago, a week or so ago, was about the harmonic profile of a Melodier Deluxe, and it had a very interesting parabolic shaped harmonic profile from the fundamental to the second, third, fourth, fifth, all the way out. This one is, you'll see, is not so entirely different. Let us get set up here and we'll discuss that. Okay, well, we're driving it now at about 500 hertz from a SG505 oscillator, very low distortion, and here is our harmonic profile. Here is 500 hertz. I've got it set to start 500 right there, and I've got a frequency span of 500 hertz per division. If we move it right over there we go. There's our second harmonic, third, fourth, fifth, sixth, seventh. It's just pretty amazing. It doesn't have that exact profile of the Melodier Deluxe, but it has one very similar.
And significantly different than the Fender.
Significantly different than, yes, the modern day amps. You'll have to, can't document everything here at once. You'll have to look at some of the other videos to see the difference. And here's what it looks like on an oscilloscope. It is not, the sine wave is not triangular. Actually looks pretty good. Let's run it up to 1 kilohertz, since that's pretty much where everything gets tested. There it is, 1005. There's its harmonic profile there. Let's change, well, we can leave it there. 0 is over here, so 500 hertz is later. Now let's put it at 1, just so that everything makes sense. There we go. Second, third, fourth, fifth. And if we go this way, we can see more. It's a little different, but there are a lot of harmonics in it. A lot. In this case, the third is a little bit higher. We're running at pretty low power, 3 squared divided by 8. That's just a little over a watt. If we run it all the way up to clipping, we get clipping right there. This is a single-ended amp, it's not push-pull. You might be able to see a little better. See the clipping right up there. And then this is our harmonic profile. Second, third, fourth, fifth is way down. 6, 7, 8. So there it is. It is what it is. And that's up at 4.5 squared divided by 8. A little over, yeah, 2 to 3 watts. But actually, quite a lot of volume when it's played. Okay, our next amplifier is a Fender Deluxe schematic. This is what we're looking at right now, but the amplifier right here is built by Doug. It's absolutely beautiful, and I can't tell you much about it, but he can. Go ahead.
Okay, this is the first amp. It's a clone of the first amplifier that Fender ever made. back in 1946. In fact, it was in a little wooden cabinet, and they call them Woody amplifiers. They trade at really high value. They're like $3,000 items now. And since I couldn't afford that, I decided I'd make one. I got the schematic, 6 SC7 preamp, and 6 N7 phase inverter, 2 6V6s and push-pull. Pretty conventional 5Y3 rectifier, but I added a bunch of the upgrades, the 1.5K grid resistors, 470 ohm plate resistors, things that Fender learned later that they should have done in the first place. I did it for this to maintain some sort of stability and reliability. End result is, I think you're going to hear the sound of an amplifier from about 1946. It's kind of the granddaddy of all Fender amps. I'm going to turn it around. Now, the speaker in here is from a 1960s Baldwin organ. Normally this amp came with like about an 8, 10, or maybe even a 12-inch speaker, but always prone to overkill. I went with a 15-inch Baldwin, namely because I had one. The end result is it's fantastic. I really think the bigger the speaker, the better, and this really gives a good voice to this amp. I have the tubes range here, 6N7. The 6SC7 rectifier over on the side, and then the 2 6V6 push-pull are set to the rear. Because of the large magnet of the speaker, the tubes couldn't be in a straight line like a parade. They had to be in a group here, rectifier with transformer, and then output tubes on the right-hand side. Kind of cut down on any noise. I tried to be faithful to the original in that it was very strange. It had an instrument input with its own instrument input with its own volume control, and a microphone input with its own volume control, which makes good sense. It's like a mixer. You could plug in your instrument and then sing and have them at different levels as would suit. What you find is that one of the microphone input has a lot lower impedance and tends to be a lot louder than the instrument. Everything else pretty much the same. Okay, and we've already gone inside.
Okay, now we have this beauty hooked up to 8 ohm load up here on the wall, and we're driving it at a kilohertz at 8.5 square divided by 8, so a little over 8 or 9 watts. There's the kilohertz again, and here is its harmonic profile. Fundamental, second harmonic, third, fourth, fifth. A lot of second harmonic. Nice looking sine waves.
How about the distortion?
Very nice looking sine wave. The distortion is just under 3% THD. The types of, just some noise down here at the bottom, which is not necessarily part of the amplifier. You can get that kind of noise just from in log mode from having a cable hooked up to it. So this part down here we can ignore. It's not a significant part of what the amplifier is creating. Now let's go to 500 hertz. We'll do frequency 500 hertz. And there we go. There's our 500. Here's our sine wave. Very nice. Nothing triangular about that. Very nice. And our let's stretch it out a little bit. There we go. There's our fundamental. Or is it 500? Yes, it is. Our fundamental, second, third, fourth. Lots of second harmonic. Now if we go to linear mode here, let's look at it that way. Sometimes that's just kind of interesting. There's our fundamental again. We have to drive it off the scale. But as long as I got it in on cal here, but I'm not overdriving the input. And if we stretch this thing out, whoops, other way. It's got a second harmonic. That's about all you see in linear mode. Well, there it is. Beautiful sounding amp. Everybody says this is the one to die for, and I can't disagree. I think we're actually having some, Doug and I are still having some questions about, we know that even harmonics tend to sound good and odd harmonics tend to not.
That's what we've been told.
That's what we've always been told, but I'm not so sure anymore. There it is, for what it is. Okay, and this for fun here, we have a Behringer GMX112. We're going to document. Very clean. Driving 8 ohms. Right now I'm driving channel 2 and up to 6%. 14.6 squared divided by 8 is its power, about a kilohertz. There's its harmonic profile. Second, third, fourth, fifth. Pretty interesting. Pretty interesting. That's what a kilohertz looks like across an oscilloscope. There it is again. Now if I go to channel 1, right here, we got a hi-fi amp now, 0.6%. There's our fundamental, and all of our harmonics are 50 to 60 dB down. Very clean. At a good bit of power, 18.6, where I think it's about 40 watts. So it's doing a reasonable amount of power. Nice looking sine wave. Like I said, I guess you can play your stereo through it in that mode. Let's go down to 500 hertz just cause we can. Okay, it's overdriving it now, so we'll back it down to where we're not clipping anymore. Right up to clipping and below. 0.2%. Holy mackerel. We do have a hi-fi amp here, don't we? And looky there, we got our fundamental and yeah, it's about peaking out there at the top, and the second harmonics is 60 dB down. And there's nothing else out there. That is channel 1. We go to channel 2. Well, that didn't work. There it is. Channel 2. At 500 hertz. Not the same. Distortion way down. I do not know enough about this amplifier to crank in things. I do have the effects. I do have everything all the way up. Did that on purpose. Here's our drive. Of course, I can change the drive over here too. No, that's not it. Well, anyway, I'm fumbling now. Anyway, this is a solid state amp. And there it is.